Alright, and welcome back. In this video, we are going to be going through Chapter 8, Section 2, titled The Pythagorean Theorem. By the end of this video, we should be able to state and apply the Pythagorean Theorem. So please have out your guide and notes. Let's begin. So the Pythagorean Theorem is something that you may have heard of before, but we're really going to be working with it a lot this chapter because this chapter is all about right triangles, and we are able to use the Pythagorean Theorem specifically for right triangles for now. And the Pythagorean theorem says, in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. So if angle C in triangle ABC is a right angle, then A squared plus B squared is equal to C squared. And we can use this in an example. In example number 1, we are asked to find the values of x. And remember that the length must be a positive number, so you're only interested in positive roots. We are given two different scenarios. We're given, for A, we have legs of 5 and 12. We want to find the hypotenuse. And for B, we have a leg of 4 and x with a hypotenuse of 2 root 5. Over for A, we're going to have x squared is equal to 5 squared plus 12 squared. You could also set up your equation as 5 squared plus 12 squared is equal to x squared. As we solve, we end up with 25 plus 144 gives us 169. As we take the square root of x squared and 169, we end up with 13. So x has to be 13. For B, we can set it up, again, c squared is equal to a squared plus b squared, or a squared plus b squared is c squared. So we have 2 root 5 squared plus x squared plus 4 squared. We simplify that down, we get 20 is equal to x squared plus 16. Subtract 16 on both sides, we end up with 4. So therefore, x is going to be equal to 2. This is a great time for me to remind you of something that we may have forgotten. If we have, for example, x plus 2 squared, it is not x squared plus 4. That is not the same thing. We have to write it out as x plus 2 times x plus 2. And now we multiply the binomials together and we end up with x squared plus, what's that, 4x plus 4. So please keep that in mind as we start to practice here. And as I talk about practicing, please work on problems 1 through 8 on the guided notes and resume when you're ready to move forward. In example number 2, we are asked to find the values of x for these 3 different scenarios. Well, for A, we have, looks like a parallelogram because we have 2 opposite sides of parallel lines. We have one side is 6 and the other side is 9. We are asked to find the value of x, knowing we have a right angle, which is very, very important for us. For B, we have 2 triangles that are adjacent to each other, and they do have a right angle. We have the hypotenuse is 13 and the entire length is 10. And for C, we're given that AC is equal to 12 and BD is equal to 16. So for A, as we start to solve over here for A, the figure is a rectangle, so the opposite angles are going to be congruent. So therefore, x squared, the diagonal, is equal to 6 squared plus 9 squared. We simplify that down, we get 117 is equal to x squared. And now we have to take the square root of 117, which simplifies down to 3 root 13. For B, the altitude is drawn to the base of an isosceles triangle, is perpendicular to, and it bisects the base. So we're going to know that we have x squared plus 5 squared is equal to 13 squared, because 5 is half of 10. X squared is going to be equal to, x squared plus then 25 is equal to 169, and we subtract 25 on both sides. End up with x squared is equal to 144. Take the square root of both, and we end up with 12. For C, though, the diagonals of a rhombus are perpendicular bisectors of each other, which is great to know. So we're going to have x squared is equal to 6 squared plus 8 squared. So we're taking half of AC, half of BD. End up with x squared is equal to 100 because 36 plus 64 is 100. And we take the square root of both sides, end up with 10. With this in mind, please work on problems 6 through 22 on the guided notes. Keep up the great work. Keep making yourself proud. Let us know if you have any questions, and we'll talk to you soon.